All right, let's talk about building a network that can actually take a punch. We're going to dive into the art of creating a truly resilient network. First, we'll look at the kind of fragile setups most people have, and then we'll see how to transform them into something robust, something scalable, something that can handle, well, pretty much anything.
So let's kick things off with a simple question, but it's a really important one. Can your network survive a pug? Seriously, what about a curious toddler? Or hey, just someone tripping over a cable? If one tiny little accident can bring your entire network to its knees, well, you've got a serious design flaw on your hands.
And that's what we're calling the pug test. See, before you can build a great network, you've got to know what a bad one looks like. And believe me, this kind of flimsy, fragile design, it's everywhere. You see it all the time, especially with new businesses just starting out. Okay, so this right here, this is probably the most common bad design out there. It's called daisy chaining. It makes sense, right? You run out of ports on your first switch, so what do? You just plug a new switch into the old one. And when that one's full, you plug another one into it. And yeah, technically it works. But what you can't see is that it's hiding a huge, massive vulnerability.
And this is where the pug test gets real. Let's imagine your pug, we'll call him Moses, gets a little snacky and chews through this one cable. Just one. Boom. Instantly, every single device connected to that second and third switch is dead in the water. They're totally, completely cut off from the rest of the network.
What you're looking at is the classic definition of a single point of failure. It's that one piece, that one link, that if it goes down, the whole system collapses. And let me tell you, in a professional setting where downtime literally means losing money every single second, this is the absolute #1 thing you have to design out of your network, ever. Okay, so how do we fix this mess? Simple. We ditch that fragile chain and we move to a much, much smarter design called the two-tier architecture. This is like a fundamental building block of modern professional network design. And you can see the difference right away, can't you? Instead of that long, vulnerable line, we now connect every switchback to one single central switch. This is called a star topology, and it completely gets rid of that cascading failure problem. Now, if a cable gets chewed, only the devices on that one switch lose connection. Everything else stays up and running. Now that switch in the middle, it's not just any old switch you'd buy at the store. Nope, it's a special piece of kit called a multi-layer switch or a layer 3 switch. The easiest way to think about it is like a hybrid. It's got the pure, raw speed of a switch, but it also has the brains of a router. This lets it manage traffic between all the different parts of your network, and it does it blazing fast. And this new setup gives us our 2 tiers. You've got the access layer, those are the switches on the front lines, where your computers and phones actually plug in. Their only job is to give you access to the network. And then you've got the distribution layer. That's our powerful central switch. It's like the network's traffic cop, gathering up all the data and telling it where to go. Okay, so our network is way, way better now. But it's not perfect. Not yet. We got rid of a bunch of failure points, that's for sure, but there is still one huge, glaring weakness that we absolutely have to fix if we want this thing to be truly resilient. Take a look. Can you see what it is? We've made all the connections to our devices more resilient, but what happens if that big, powerful distribution switch in the middle dies? Yep, you guessed it. The entire network goes down. All we've really done is move our single point of failure from a cheap cable to a much bigger, much more expensive box. So the solution is a word you're going to hear a lot in networking. Redundancy. We just duplicate the most important hardware. So first we add a second distribution switch, then we add a second router. And here's the really crucial part. Every single access switch now gets a cable going to both of the distribution switches. So now, if any one device fails, a switch, a router, a cable, the traffic just instantly finds another way to go. The network doesn't even blink. It just stays online. Of course, there's a catch. This beautiful, perfectly redundant design has one major, real-world problem: cost. I mean, every single piece of that extra hardware, especially those high-end switches and routers, they can cost tens, even hundreds of thousands of dollars. So network design is always a trade-off. It's a negotiation between that perfect, never-fail design and what the company can actually afford to spend. So money is one challenge, but the other big one is scale. What happens when your company gets so big it's not just in one building anymore? What if you have a whole campus of buildings?
Well, that's when our nice two-tier model starts to kind of fall apart. If you try to connect the main switch in every building to the main switch in every other building, you end up with this total mess, a spider web of cables that's impossible to manage. It's just not scalable. You'd run out of ports on your switches in no time, and they wouldn't have the horsepower to handle all that traffic anyway. The solution, thankfully, is actually pretty elegant. We just add a third layer. So you keep your access and distribution layers inside each building, just like before. But then you add a brand new, super-duper fast core layer. And the only job of this core is to be a lightning-fast backbone that connects all the different buildings together. And that core layer switch, it's a beast. It's built for one thing and one thing only: speed. It doesn't do any fancy security stuff, no complex filtering. The best analogy I've ever heard is this. It's like that massive guy at the gym. All he does is grunt and lift heavy things. He's not there to think, he's just there to be powerful and fast. That's the core switch. Its whole reason for existing is to move insane amounts of data as fast as humanly possible, creating that super reliable backbone for the whole campus.
So now we've got two really solid design models, right? The two-tier and the three-tier. And the trick is just knowing which one to use for the job, because as you'll see, they're actually very closely related. You know, there's actually a proper industry name for that two-tier model we started with. It's called a collapsed core, and it makes perfect sense when you think about it. You're basically taking the job of that super fast core layer and collapsing it down into the distribution layer, which now has to do both jobs. And honestly, for most companies that are just in one office or one building, this is totally fine. It's more than enough. So let's break it down. When do you use which? The two-tier model, the collapsed core, that's your go-to for small to medium-sized businesses that are all under one roof. It gives you good scalability, and it doesn't break the bank. The three-tier model, on the other hand, that's for the big leagues. We're talking large enterprises, university campuses, places with multiple buildings that need that dedicated core for absolute maximum speed and scalability. And that brings us right back to where we started. You know, your network at home, or maybe even the one at your office, it probably works just fine on a normal day. But the real question you should be asking is it resilient? Can it actually survive the pug test? Because at the end of the day, a network that just works isn't good enough. What you really want, what you should be aiming for, is a network that's designed from the ground up to never, ever fail.